Today we are reproducing an exploit that happened on Punk protocol. Reading about those things and especially reproducing them is a great way to learn how to make your smart contract safe, so that you know what hackers actually do to exploit smart contracts and what mistakes to avoid. So let's start. Here we are on the page on rekt.news, and they are pretty good at reporting all of the exploits. If you go to the main page, you can see that it happens all the time, so you better start reading this. And today we selected an article which is pretty easy to reproduce, because if you read those, you can see that often they say how the hacker did the exploit, and they show snippets of code, say what functions were triggered, and also show the transactions. So anytime you can find the transaction number and see what happened there. So let's go back to the article and see what went wrong in this case. And right here, you can see that the hacker was able to trigger the initialize function to change forge address to an address of their own. And this way, if they were a forge, they could access functions with only forge modifiers, allowing them to withdraw all of the funds from the contract. So now we know what happened here, but what do we do with this? Of course, we are not gonna go and try to do this again on this project, but we have to create the same environment that was there back then. And to do this, in most of the cases, you can go to GitHub. And on GitHub, I found the Punk protocol. And here I have the smart contracts. So if I go inside and compare what I read about in the article to what I see here, I see forge, I see the CompoundModel with all of the withdraw functions, like withdraw to, withdraw all to forge. So just what I'm looking for. And now what we need to do is just to fork this project, just clone it. But then again, this exploit happened like 2 years ago. So we can't use a version of the repository with all of the bug fixes that probably fix the problem. And yeah, indeed, if we go to the problematic file that was exploited, problematic contract, and scroll down to initializer, we can see that initialize now use the initializer only created modifier. So let's go back and try to access the previous version of the repository. And to do that, I'll just check the history of this file. And here I need to find a commit which fixed the issue. So we can see a comment which says something about the hack. So let's try the previous version and let's see whether this time the issue still occurred. So I'll just expand the compound model. And here I can see that there is no initializer, no modifier, so it was to be executed by anybody. Though now we access the compound model, the previous version of it, but if we want to access the whole repository, we can just go back to the list of the commits, select the one that we are interested in, and click this button, which will browse the repository at this point in history. And immediately you can see that we are on a special branch with a generated name. So now you can browse the whole repository, or you can download it and just copy this link. But what we want to do is we want to open it in Remix. Go to the master branch of this repository, check the history, and find the commit with the bug fixes for the exploit. And here you can see that it's the commit that fixed the problem. So we need to know how many commits we want to clone. So it's 4 or 5 commits, because we want to check out to this one. So let's go to Remix and clone the repository with depth of 5 commits. And I'll be using the digit plugin, which lets us use Git here, and select the depth, and I set it to 5. I don't need all of the branches. I need only the master branch. And now I can click on clone. The repository is cloned, but now if I open the contract that I want to exploit, you can see that there's the initializer and only creator, so it's after the fix. So now we need to check out to the revision of the repository before the fix. So to do that, we need to go to commits and find the commit that fixes the problems. So it's this one, and we check out to a commit before this. So now I'm check out. I can check the same exact smart contract. And yeah, there's no modifier, so it's the one that you want to exploit. Now the smart contracts are ready, but we want to deploy them to make the application live so that we have something to exploit. And to do this, I'll just deploy the compound model, which we want to exploit. You can do this all locally, it doesn't matter here, you don't need to use a live network. And now, let's say I'm an admin who creates this, who runs this protocol, and I want to initialize my compound model. So you can see that it requires us to paste a lot of addresses. So we'll need to check which ones will be required to run the exploit and which ones we can omit because they are not important in this case. So forge for sure will be important, so we need to paste something here. But let's say we paste an address of our account because we will be interested in changing this to another address which will try to steal the funds. For token and C token, you can see that those are important because if you scroll down to the withdraw functions, you can see that they operate on C token and the ERC20 token. So exactly those two addresses. So we would need to create a new ERC20 token and a new even mocked C token just so that the code will compile. Looking at this code, you can see that the C token is supposed to redeem underlying amount and send it to ERC20 token, but I'm not really interested in making the redeem underlying method. It's not the point of this video, so I'll just mock this by adding the amount here, so that the new balance would be just like the old balance, but plus the amount I assume I would redeem from the C token. You can see down below that then the contract will subtract old balance from new balance, so it will leave us at the amount we specified in the argument, and we'll try to send the amount to our address from the ERC20 token. So now what we need to do is we need to create ERC20 token and C token, and C token means compound token. And I already created very simple implementations. Here is my ERC20 token, and let's say that it will only mint 10,000 tokens for the admin address which will deploy this token. And I also have a mint function. It doesn't even need to be payable. Let's say it's only public. In the real world, it would have an only owner, a modifier, or something else that will keep all of the other users from minting this. But this is only a mock, so we don't need to care about this here. So let's deploy the my token. And then I want to mint some tokens for the compound model. So for the smart contract, we'll be exploiting later on. So I'll use the mint function, paste the address of the compound model, and paste the amount. So let's say like maybe 1,000 Wei. And keep in mind that it's not going to be 1,000 of tokens because there are decimals. So it will be a fraction of a token. But it's alright for test purposes. You can go for a higher number if you want. So I minted the tokens for compound model. So I can collapse the my token, and ERC20 is ready. So what we want to do now is to create a compound token. And I have a very simple implementation, which, as you can see, looks completely like a stub, like a mock, and it returns just zeros. But what I'm interested in is that the program will compile and the transaction will go through. As you saw before, we created a workaround for the redeem underlying so that we don't have to implement all those chain guns and hundreds of lines of code, because that's not the point of the exploit. So now I'll just deploy the C token. And it's deployed here. So now I'm able to copy those both addresses and paste them to the initialize function. And let's see what we are left with. We are left with comp, controller, and urouter. If you analyze the smart contract and go to the withdraw functions and check what's used here, we can see that those addresses are not quite used here. So let's just paste anything, maybe the address of the deployer. We do this only because they have no impact on our experiment and they will not be run in the functions we are interested in. So let's run this transaction. Let's see whether the underlying balance functions work properly. And indeed, they return 1000. And 1000 is the amount we minted for the ERC20 token. And also, let's check whether the token at the index of 0 is the one that we deployed and plugged in. And you can compare the addresses. And this one starts with 0xD8, and this one is D8 too. It's the exactly same one. You can also click on Forge, and you can see that it's the address of our MetaMask. I zoomed it a bit so that you can see the details better, but now let's switch hats and let's become the exploiter. So I'll change the address to change the account to another one. And right now, I shouldn't be able to access any protected functions in this smart contract. So if it used an ownable, if it expanded the ownable contract and used only owner, I wouldn't be able to access it because I'm not the admin. As well as if this initialize function used only owner, only initializer, or any protection, I wouldn't be able to access this. But that's not the case. It's a public function, so I'm able to use it. Though, if I want to run the exploit in my smart contract, because, for example, I want to batch all of the transactions so it happens at once and I don't have to trigger all of the functions manually, I can use an attack contract, which I have here. And you can see that in this contract, I'm accessing the model interface because that's the interface used by CompoundModel. And you can find the model interface in the interfaces package. And here it is. Though, as you can see, this interface doesn't have the initialize function. So I just copied the whole thing from here and created my model victim interface with the initialize function here. So that I'll be able to access both initialize to change the forge address and also withdraw to withdraw the funds to my wallet. So let's go back to the attack contract, and here I just import this new interface. And here I paste the address of the contract I want to exploit. So I'll have to update this address and copy it from here. Now it's replaced, so I can save the contract. And then, like before, forge address, now it's going to be my address because I want to change it to my address so that I can withdraw everything to forge. So indeed, again, my address. Comp, controller, urouter, v2, it didn't matter and it doesn't matter now either. So I'll just paste my address again. And token and C token, I'll just pass them in as parameters here and then use them in the victim initialize function. Right after calling the initialize function, I'll call the withdraw to forge. But I need to pass an amount here. So I need to say how much I want to withdraw, and I could use it manually. I could create a loop that withdraws, for example, 10,000, then 10,000 again until you drain the whole wallet. But I also could use the already provided method that comes in handy, underlying balancing model. It seems to return the number that's available for the withdrawal as checked here. It returns 1000, so indeed exactly what we minted for the smart contract. Obviously, we do this only for education purposes, so don't try to exploit any real smart contracts, but feel free to improve your security skills by practicing those exploits on testnets. So now we are deploying the attack contract as the second account. It's ready, and we can trigger the attack function right after pasting the addresses. We send the transaction, and as you can see, it went through. So now we can check the results. Go to the compound model, and let's check who's the forge. You can see the previous result here, but now as I click on forge, you can see that it changed to my address. So now I'm a forge, and I just withdrew all the funds. Also, if I click on the underlying balance functions, you can see that it's zeroed. What's next is if I go to the my token, and remember we minted the 10,000 fraction of a token for this address, but now let's check its balance. It should no longer be 1000. But if I check my balance, and paste it here, it's gonna be 002, and that's because we took the funds, but we left them in the smart contract. So if we copy the address of the attack contract, we can see that it's 1000. So at this point, it's up to the hacker what to do with the funds, whether he wants to continue the transaction and send them elsewhere, or just withdraw them to their own wallet. But we don't really care about this right now. So what we wanted to do is to withdraw all the funds, and we did this. As you can see, really small mistakes like this can cause pretty huge problems. You can lose a project over something like this. So make sure to check all of the newest exploits to know what the hackers exactly do to the smart contracts. And try to, if you are a developer, which I assume you are, try to practice on those examples. And if you want to see other videos like this, we are considering to make a series out of this and reproduce all of the other hacks. So if you are interested in it, make sure to let us know by leaving a comment, leaving a like, and this way we will know whether you want to see this or we should just leave it to ourselves. Also, if you are interested in making your smart contracts secure, make sure to check Ethernaut. It's a great tool created by OpenZeppelin in which you can test your security skills and exploit the smart contracts. Here you get a contract to exploit, read instructions, and then you're ready to go and exploit the contract using console. I think that's also an excellent way to practice. So if you are interested in it, you can check our Ethernaut series, and we created 12 episodes of this. So it's more than enough to get you started with the security things. Also, there are other ways to make your smart contract secure. We'll be releasing new videos about Forta and about normal sentinels in OpenZeppelins, so a way to monitor your smart contracts and get notifications when something bad happens to them, or where something suspicious starts happening, so that you can react to this quickly and prevent the problem, or at least be aware of it if it happens, as well as all of the other videos like plugins for Remix, Guild XYZ for your community, and automatic blockchain oracle. So make sure to subscribe, leave a like, leave a comment. Thanks, and see you next time.